When a builder plans to finish a garage for use as office space, all general requirements for receptacle placement and spacing must be met. The National Electrical Code, or NEC, establishes minimum standards for electrical installations. These standards ensure the safety and functionality of electrical systems, applying to all electrical installations irrespective of their intended use. Even with plans to revert the office space back into a garage in the future, the electrical installation must still adhere to NEC requirements. The space will be used as a workspace and therefore must have a safe and functional electrical system. The NEC dictates that receptacles should be placed so that no point along a wall is more than 6 feet from a receptacle. Furthermore, receptacles must be spaced so that there is at least one receptacle for every 12 linear feet of wall space. These stipulations aim to ensure an adequate number of receptacles to meet occupant needs and to locate them in convenient spots. In addition to the general requirements for receptacle placement and spacing, specific rules apply to receptacles within garages. The NEC mandates that garages have a minimum of one receptacle on each wall, positioned within 12 feet of the garage door. These requirements are intended to ensure an adequate number of receptacles to meet occupant needs and to locate them in convenient spots. By adhering to the NEC requirements, the builder ensures that the electrical installation within the garage is both safe and functional, regardless of its future use. The NEC guidelines for receptacle placement are designed to minimize the use of extension cords, which can be a fire hazard and a tripping hazard. Adequate receptacle spacing also prevents overloading circuits, which can cause breakers to trip or, in extreme cases, lead to electrical fires. Firstly, general requirements dictate spacing. The 6-foot rule means that no point along a wall line should be more than 6 feet from an electrical outlet. This measurement is typically taken horizontally along the wall line. Secondly, the 12-foot rule, ensuring an outlet every 12 feet along the wall, complements the 6-foot rule. It ensures a reasonable distribution of outlets throughout the room. Thirdly, specific requirements dictate placement in garages. Garages require at least one receptacle on each wall. Additionally, one receptacle must be within 12 feet of the garage door, intended for powering tools or equipment used in or around the garage entrance. This receptacle is often placed near the garage door opener. Fourthly, countertop receptacles, while more relevant to kitchens and similar areas, might be a factor if the office design includes countertops. NEC guidelines specify spacing for countertop receptacles, ensuring easy access to power for appliances and devices. Fifthly, island and peninsular countertops also have specific receptacle requirements, if the office design includes such features. These requirements are in place to minimize reliance on extension cords across countertops. Sixthly, bathroom receptacles are required to be ground fault circuit interrupter, or GFCI, protected. Although this is mainly for bathrooms, if the office includes a sink area, a GFCI receptacle is necessary. Seventhly, outdoor receptacles, if present for exterior access, must be GFCI protected and weather resistant. Eighthly, dedicated circuits are required for certain appliances or equipment. If the office space includes appliances that require dedicated circuits, these must be installed. This typically includes items that draw a significant amount of power, such as a mini fridge or a microwave. Ninthly, arc fault circuit interrupter, or FSI, protection is generally required for most circuits in a dwelling unit. This protection helps prevent electrical fires by detecting arc faults. Tenthly, receptacle height is not explicitly defined in the NEC. Local building codes may dictate the minimum or maximum height at which receptacles must be installed. When converting a garage into office space, several electrical considerations beyond receptacle placement must be addressed. Firstly, proper wiring and circuit capacity are crucial. Evaluate the existing wiring in the garage to ensure it can handle the increased electrical load of an office environment, which typically involves computers, printers, lighting, and other electronic equipment. Consider upgrading the wiring and adding new circuits to accommodate the anticipated load. Secondly, lighting is vital for an office space. Plan for adequate lighting, combining ambient task and accent lighting. Consider energy-efficient options such as LED fixtures. Ensure compliance with energy codes regarding lighting power density. Thirdly, heating and cooling systems must be considered. Evaluate the existing heating and cooling system to determine if it can adequately maintain a comfortable temperature in the converted office space. If necessary, install a separate heating and cooling system or supplement the existing system. Fourthly, ventilation is important for air quality. Ensure proper ventilation in the office space to prevent the buildup of stale air and pollutants. Consider installing an exhaust fan or upgrading the ventilation system. Fifthly, smoke detectors and carbon monoxide detectors are essential safety devices. Install smoke detectors and carbon monoxide detectors in the converted office space, following local building codes. Sixthly, grounding and bonding are critical for electrical safety. Ensure that all electrical equipment and systems are properly grounded and bonded to prevent electrical shock hazards. Seventhly, surge protection helps protect sensitive electronic equipment. Consider installing surge protection devices to protect computers, printers, and other electronic equipment from power surges. Eighthly, electrical panel upgrades might be necessary. If the existing electrical panel does not have sufficient capacity to handle the additional load of the office space, upgrade the panel. Ninthly, permits and inspections are generally required. Obtain the necessary permits from the local building department before starting any electrical work. Schedule inspections to ensure that the work complies with the NEC and local building codes. Tenthly, professional electrical assistance is recommended. Hire a qualified electrician to perform the electrical work. An electrician can ensure that the work is done safely and correctly, and that it complies with all applicable codes and regulations. The NEC is a comprehensive set of standards that aims to minimize electrical hazards and ensure safe installations. Firstly, proper grounding and bonding are crucial. Grounding provides a path for fault current to return to the source, tripping the circuit breaker or fuse and de-energizing the circuit. Bonding connects all metal parts of the electrical system to create an electrically continuous path, further reducing the risk of electric shock. Secondly, overcurrent protection is achieved using circuit breakers and fuses. These devices protect circuits from overloads and short circuits, which can cause overheating and fires. Circuit breakers are resettable, while fuses must be replaced after they blow. Thirdly, ground fault circuit interrupters, or GFCIs, protect people from electric shock. They monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoors. Fourthly, arc fault circuit interrupters, or RFCIs, detect arc faults, which are dangerous electrical conditions that can cause fires. RFCIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Fifthly, wiring methods are specified by the NEC. The NEC specifies the types of wiring that can be used in different locations and applications. Common wiring methods include non-metallic sheaths cable, or NM cable, also known as Romex, and electrical metallic tubing, or INT. Sixthly, box fill calculations are required to ensure that electrical boxes are not overcrowded. Overcrowded boxes can lead to overheating and fires. The NEC specifies the maximum number of wires and devices that can be installed in an electrical box based on its size. Seventhly, conductor ampacity is the maximum amount of current that a conductor can safely carry. The NEC specifies the ampacity of different sizes and types of conductors. It is important to select conductors with adequate ampacity to prevent overheating and fires. Eighthly, voltage drop is the reduction in voltage along a conductor. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Ninthly, equipment listing and labeling ensures that electrical equipment has been tested and certified by a recognized testing laboratory. Listed and labeled equipment meets safety standards and is suitable for its intended use. Tenthly, working space around electrical equipment is required for safety. The NEC specifies the minimum amount of working space that must be provided around electrical equipment such as electrical panels and transformers. This working space allows electricians to safely inspect, maintain, and repair equipment. When planning an office space, consider the specific electrical needs of the equipment and users. Firstly, assess power requirements. Determine the total power consumption of all equipment that will be used in the office, including computers, printers, lighting, and appliances. This will help determine the appropriate size of the electrical service and the number of circuits needed. Secondly, plan for dedicated circuits. Consider providing dedicated circuits for equipment that draws a significant amount of power, such as computers, printers, and copiers. This will help prevent overloading circuits and ensure reliable operation. Thirdly, provide adequate receptacles. Provide an adequate number of receptacles to meet the needs of the office users. Locate receptacles in convenient locations, considering the placement of furniture and equipment. Fourthly, consider surge protection. Protect sensitive electronic equipment from power surges by installing surge protection devices. This can help prevent damage to equipment and loss of data. Fifthly, plan for data and communication wiring. Install data and communication wiring to support the office's network and communication needs. Consider using structured cabling to ensure reliable and efficient communication. Sixthly, address lighting requirements. Plan for adequate lighting, combining ambient, task, and accent lighting. Consider energy-efficient options such as LED fixtures. Seventhly, consider accessibility. Ensure that receptacles and other electrical equipment are accessible to people with disabilities. Follow accessibility guidelines such as those outlined in the Americans with Disabilities Act, or ADA. Eighthly, address future expansion. Plan for future expansion by providing additional electrical capacity and wiring. This will make it easier to add new equipment and users to the office in the future. Ninthly, ensure compliance with building codes. Comply with all applicable building codes and electrical codes when installing electrical systems in the office space. Tenthly, seek professional guidance. Consult with a qualified electrician or electrical engineer to ensure that the electrical systems are properly designed and installed. The conversion from a garage to an office space has some important considerations. Firstly, consider insulation and climate control. Garages are often uninsulated or poorly insulated. Adding insulation to the walls, ceiling, and floor will help to improve energy efficiency and create a more comfortable office environment. Consider the need for heating and cooling systems to maintain a comfortable temperature. Secondly, address moisture control. Garages can be prone to moisture problems. Inspect the garage for any signs of leaks or moisture damage. Install a vapor barrier to prevent moisture from entering the office space. Thirdly, deal with fire safety. Garages are often used to store flammable materials. Ensure that the converted office space meets fire safety requirements, including the installation of smoke detectors and fire-resistant materials. Fourthly, consider the floor. Garage floors are typically concrete. Consider covering the concrete floor with a more comfortable and aesthetically pleasing flooring material such as carpet, tile, or wood. Fifthly, address soundproofing. Garages can be noisy. Consider soundproofing the walls and ceiling to reduce noise transmission from outside. Sixthly, think about natural light. Garages often have limited natural light. Consider adding windows or skylights to increase natural light in the office space. Seventhly, think about the door. The garage door may need to be replaced with a more secure and aesthetically pleasing door. Consider installing a pedestrian door for easy access to the office space. Eighthly, consider aesthetics. The converted office space should be aesthetically pleasing and functional. Choose colors, materials, and finishes that create a comfortable and productive work environment. Ninthly, address code compliance. Ensure that the converted office space complies with all applicable building codes and zoning regulations. Tenthly, seek professional guidance. Consult with a qualified contractor or architect to ensure that the conversion is done safely and correctly. When dealing with electrical work, ensure safety by adhering to lockout, tagout, or LOTO procedures. Firstly, identify the circuit. Before working on any electrical circuit, identify the circuit breaker or fuse that supplies power to the circuit. Secondly, de-energize the circuit. Turn off the circuit breaker or remove the fuse to de-energize the circuit. Thirdly, verify de-energization. Use a voltage tester to verify that the circuit is de-energized. Test each conductor to ground and between conductors. Fourthly, lock out the circuit. Place a lock on the circuit breaker or fuse box to prevent it from being accidentally turned on. Fifthly, tag out the circuit. Attach a tag to the lock indicating that the circuit is de-energized and should not be turned on. Sixthly, test the voltage again. Before starting work, test the voltage again to ensure that the circuit remains de-energized. Seventhly, keep the key with you. Keep the key to the lock with you at all times. Do not give the key to anyone else. Eighthly, inform others. Inform others in the area that you are working on the electrical circuits and that it should not be turned on. Ninthly, use insulated tools. Use insulated tools when working on electrical circuits. Insulated tools provide protection from electric shock. Tenthly, follow safety procedures. Follow all safety procedures when working on electrical circuits. If you are not comfortable working on electrical circuits, hire a qualified electrician. When converting a garage into an office in Florida, certain specific aspects of the Florida Building Code and local regulations must be considered in addition to the NEC requirements. Firstly, wind load requirements are present. Florida is a high wind zone, so ensure that the structure of the garage and any modifications meet the wind load requirements specified in the Florida Building Code. This may involve reinforcing the walls, roof, and garage door. Secondly, energy efficiency standards are a consideration. Florida has strict energy efficiency standards for buildings. Ensure that the converted office space meets these standards, including requirements for insulation, windows, and HVAC systems. Thirdly, hurricane protection must be addressed. If the garage is located in a coastal area, it may be subject to hurricane protection requirements. This may involve installing hurricane shutters or impact-resistant windows. Fourthly, flood zone regulations might apply. If the garage is located in a flood zone, it may be subject to flood zone regulations. This may involve elevating the office space or floodproofing the structure. Fifthly, permitting processes must be followed. Obtain the necessary permits from the local building department before starting any construction work. This will ensure that the work complies with the Florida Building Code and local regulations. Sixthly, inspection requirements are present. Schedule inspections with the local building department to ensure that the work is being done in accordance with the approved plans and the Florida Building Code. Seventhly, licensed contractors may be required. Certain types of construction work, such as electrical and plumbing work, may require a licensed contractor. Eighthly, zoning regulations must be followed. Comply with all applicable zoning regulations, which may restrict the use of the property or the types of construction that are allowed. Ninthly, homeowners association rules must be addressed. If the property is located in a homeowners association or HOA, comply with all applicable HOA rules and regulations. Tenthly, professional guidance is recommended. Consult with a qualified architect, engineer, or contractor to ensure that the conversion complies with all applicable codes and regulations. The Florida Building Code references the NEC, but local amendments and interpretations can exist. Firstly, understand local amendments. Check with the local building department for any amendments to the Florida Building Code or the NEC that may be specific to the jurisdiction. Secondly, verify permit requirements. Confirm the specific permit requirements for converting a garage to an office space with the local building department. Thirdly, clarify inspection procedures. Understand the inspection procedures and requirements with the local building department. This will help ensure that the project passes inspection smoothly. Fourthly, confirm licensed contractor requirements. Determine which aspects of the project require licensed contractors, such as electrical, plumbing, or HVAC work. Fifthly, address zoning compliance. Verify that the proposed office space complies with local zoning regulations regarding setbacks, parking, and other requirements. Sixthly, address HOA requirements. If the property is subject to a homeowners association, obtain approval from the HOA before starting any construction work. Seventhly, ensure proper documentation. Keep all documentation related to the project, including permits, plans, inspection reports, and contractor licenses, in a safe place. Eighthly, address safety concerns. Prioritize safety throughout the project by following safe work practices and complying with all applicable safety regulations. Ninthly, address liability concerns. Ensure that you have adequate insurance coverage to protect yourself from liability in case of accidents or injuries. Tenthly, seek professional advice. Consult with a qualified architect, engineer, or contractor to ensure that the project is done safely and in compliance with all applicable codes and regulations.